Hi folks, welcome back to the lab. So I've always wondered if there is any appreciable difference between sodas that have been made with corn sugar versus cane sugar. Chemically, these are different, and I think that this dextrose should taste a little bit less sweet than sucrose, but we're going to do a taste test later on. But one thing I really want to know is if the sodas that are being made today using glucose fructose syrup are actually appreciably different than the ones made with regular sugar. So today we're going to be also making a cola using some concentrated cola. I could probably make this myself, but I don't really feel like doing that today. So we're just going to be making it with seltzer and extract. So I'm going to start with this sugar first. I do know what sugar tastes like, but for the sake of being fair, we should go ahead and taste this one first. So I'm just going to get an arbitrary amount of it. This is about maybe 3/4 of a teaspoon, and we'll see what this tastes like. Yeah, it tastes like sugar. It's pretty sweet, I would say. At least that's what I think sugar tastes like. I personally can't take sugar that well. And next we're going to do just the dry corn sugar and see if that's any different. There we go. I'd say that's about the same amounts right there. This isn't really too scientific, but it's going to be a definite difference. Wow, I would say this is by far a lot sweeter than cane sugar. Which is really weird because I've heard that dextrose is supposed to be less sweet than cane sugar, but I bet what's going on here is that the particle size of this is a lot smaller than the cane sugar. So this sugar is dissolving a lot faster on the tongue than this one is. So hopefully you can see this. It's kind of hard to tell, but the one on the left is the corn sugar, and it almost looks kind of flaky, like it's been cut up. And the one on the right is granulated sugar, and it is all very even in size and also much larger, whereas this one's almost powdery. The granules of the dextrose here are much smaller. Yeah, this dissolves very rapidly. It's even faster than I would say castor sugar, which is like a finer granulated sugar, would dissolve. That is very rapidly dissolving, and it also goes away pretty quick. So that's an interesting thing. Next, we're going to be making sugar syrups with these. I'm going to weigh out 200 grams of each of these sugars into some liquid, and hopefully we'll also be able to make some other reactions with the sugar as well. Just trying to get it close to 200 grams. There we go. Looking at these jars from the side, this one reaches up to the 300 milliliter mark. And this one is maybe around 210 or 215, which is very interesting because this one is the corn sugar and this is cane sugar. I wonder if the cane is more dense. I will be using distilled water for this. Okay, seems close enough. Okay, let's mix these up thoroughly. So this one is the dextrose and this is the sucrose. You can see the sucrose is slightly darker, probably because of impurities or something. Because I believe that the dextrose is actually chemically extracted. So, whereas this is kind of just dried. I remember it's having a really hard time dissolving. I might have to heat that up. Ooh. Now it is fairly cold in here, so I think that might be part of the reason why this sugar is having such a hard time dissolving. So I was able to get most of the sugar to dissolve, but it took quite a lot of heating. And you can definitely see here that there is a color difference between the sucrose, or I should say table sugar, and the dextrose, or corn sugar. All right, now let's do a taste test of these two different sugar syrups. Let's start with regular sugar. Again, I'm already very familiar with what this tastes like, but I did want to start with this so we can get an idea. And the way we did this is equal parts of sugar and water. And it's warm, so maybe that'll have an effect. Yeah, sugar water. There's not very much to say about that. And now let's go ahead and try the glucose water. You know, I think that the glucose water tastes more like sugar than the sugar water. It's also gone very quick. The sweetness is there and then gone. So it's really weird because you'd imagine I'm contaminating the samples, but whatever. See, this tastes more like candy or something. Whereas, let's just rinse that. Yeah, this tastes more like, it just tastes like sugar, like what I'd expect sugar to taste like. Maybe like granulated sugar that's been sitting on the table for like forever. As for sweetness though, these are all very similar. And I'm surprised by that actually, because the glucose was significantly sweeter in dry form. So I have a feeling that it was really just the granule size that was causing the glucose to taste sweeter than the sucrose. But now let's go ahead and try to convert the sugar syrup into glucose fructose syrup. And now that I'm thinking about it, I should probably prepare another sample of this with just regular sugar so we can keep it on the side. Getting it everywhere. Close enough. All right, so now we have our two sugar solutions here. These are both identical, and one of them we're going to try to do our reaction on. So very simple, we just add some citric acid and then heat up to a certain temperature. One source said that you need 1 gram of citric acid, or it said even cream of tartar, which I'm kind of skeptical about, for every 1 kilogram of sugar. Now we only use 200 grams in this batch, which means you're going to need 0.2 grams of citric acid. All right, so we have our sugar solutions mixed up here. Of course, this one has the acid in it. The other two are just sugar solutions. And I'm actually going to cook all three of these things the same way that I'm going to cook this one, which does actually need to be cooked in order for the reaction to take place. This has to be heated up to about 134 degrees Fahrenheit, I think is the number. And I'm just going to do the same thing for the sucrose and the glucose. I actually don't have any idea what will happen with the glucose syrup. I have a feeling that this will stay pretty intact. The sucrose might start to crystallize out, so we'll see what happens with this one. Alright, so that's our 3 sugar solutions done, reduced down, and they all appear to be around 200 milliliters. As you can see on the side here, there's probably been losses from just not pouring them out of the jars completely, and we're also losing quite a bit inside the pot. Alright, so it's been actually a couple of hours here, and I've kept the sugar solutions in this water bath here. Kept at a constant temperature of about 120 degrees just so that it wouldn't like crystallize, but now that I'm looking at it, I think our sucrose has actually started to crystallize a bit. That's I guess that's expected because we concentrated a lot. The sucrose that we added acid to is actually fully liquid, which is a good sign. That means that we have made a little bit of glucose fructose syrup. I don't know how much. And the glucose, yeah, it is the same as before. It is really runny compared to the sucrose syrup that we treated here. So this is a little bit thicker, but it is not nearly as runny. And that tells me that we haven't been able to convert the entirety of this to glucose fructose syrup. So there's still a lot of the sucrose left over. Spoon is acquired. And now let's do a taste test. Starting with the sucrose here, it's going to be a little bit of a weird test because a lot of it's crystallized, and I'm not really too sure if the crystals are causing the concentration of the syrup to go up or down. I'm not really sure how that works, but let's just, ooh, it's kind of thick, sugar syrup. Sweet. I think that's going to be a pretty common factor here. Is just going to be pretty sweet. And I'll just rinse this spoon off, dry it a little bit, and then we'll try the glucose next. So this one, again, quite runny compared to the sucrose. And I was looking at this when it came out of the pot, and it was quite runny. So that's interesting. Whoa, that's sweet. That is really sweet. I told you earlier I can't handle sweetness. This is really sweet. That's like chemicals. And weird thing is I've had corn syrup in the past, and it's not nearly as sweet as that. So I bet what I made today is like concentrated corn syrup. Finally, let's do our treated sucrose. Starting to get a little bit of sugar high off that. Now, the interesting thing about this, like I said, it's been definitely converted a little bit into glucose fructose syrup. But since it's thicker than the glucose, it makes me think that this isn't a full conversion, and we're still looking at a little bit of sucrose. Now, I did look this up, and there is a thing called like light syrup, more common in the UK than it is here. And apparently that is 50% sucrose. The rest of it is glucose fructose syrup. Whoa. Also, I didn't even mention before, but this is called invert sugar. So there's a name for this thing that we've made. Yeah, it's not nearly as sweet as the glucose syrup. I do want to compare them directly. So that's sugary, not that sweet. It's sweet, but tolerable. And then the invert sugar is runnier. Yeah, it's more sweet. It's sweeter, but just by a little bit, not by much. So that's the interesting test. Now let's go ahead and make a soda. So I've been thinking for a while about how to do this, and I kind of came up empty-handed because these sugar syrups are very different in sweetness. And if we use the same amount in each of these glasses, our sodas are going to be very different in sweetness as well. But I couldn't figure out any good way of doing this, so I should repeat this in the future following some research papers and just do more research in general. But anyway, let's go ahead and just get to the sodas. This is the part that I've been wanting to do for a long time now. So this is supposed to be mixed in a ratio of 1/2 ounce per gallon, which is pretty darn concentrated. And 1/2 of an ounce, well, 1 ounce is about 30 ml. So 1/2 of an ounce is about 15 ml. Let me just write in the units. Roughly 15 milliliters. That's per every gallon. Now, we are using these 12-ounce bottles of seltzer, and 12 ounces is like, I think, 3/4 of a pint. So we'll just put this right here so I can remember. These are pint glasses, by the way, but we won't be filling them up. Anyway, let's figure out exactly how much of this syrup we're going to be needing for 3/4 of a pint. So I like to think in ml because every tool I have measures in milliliters. So in a gallon, there's 4 quarts and there's 2 pints per quart, which means that there's 8 pints per gallon. So we'll divide 15 by 8, which I believe is like roughly 2. Let's just say 2. And because this is 3/4 of a pint that we're going for, we should do 1.5 ml per glass. So let's get this open. Highly concentrated soda extract here. And I bet it's probably got caramel color in it too. So I'm going to get my fingers stained on this probably permanently. But anyway, we'll just put 1.5 of these eyedroppers in each one of these glasses. I see the trick to using this thing is to squeeze it fairly slowly. Then it all comes out really clean. All right, and now we're going to add in the sugar. Now, I figured that for this amount of soda, that we should probably be targeting somewhere around 30 or 40 grams per serving is what I usually see on a bottle of soda. And our sugar syrups, if I'm doing my math right, should be around 80% concentrated sugar, well, 20% water, I should say. So we're going to weigh maybe 60, yeah, let's just go with 60 grams. Hopefully that's sweet enough. 60 grams of sugar in each one of these things. Okay. Close enough. All right. That's a gram over, but hopefully that's not going to be too much of an issue. All right, folks, now it is time for the not too terribly scientific taste test. This is going to be pretty interesting because we have our measured sugars and cola concentrate here. And theoretically, all we have to do is just add some seltzer water to it, and hopefully it should be cola. So I'm going to start with our sucrose, regular sugar, and just add a little bit to start with so we can get that sugar syrup dissolved. I don't really think measuring has to be too accurate, but we'll see. Get that stirred up. Now all that stirring is going to make our soda flat, so we'll just add the rest of the bottle and hopefully it's good enough to drink. Alright, might as well give it a taste test right now. So regular sugar in some cola concentrate. You know what? If you handed this to me, I would have never guessed that it wasn't Coca-Cola. Not sponsored. Okay, that's pretty interesting. Let's go ahead and try the glucose next. We're going to do the same thing, just a little bit of soda water in the bottom to get that glucose dissolved. Looks to me like the glucose syrup took a lot less time to dissolve there, so that's interesting to note. I'll just add the rest of the bottle of seltzer now. And we'll give it a taste. That was not at all what I was expecting. So this is way less sweet than the sucrose, regular table sugar syrup. But so the next one, which should be pretty interesting here, is our glucose fructose syrup. Actually, I think this is probably closer to invert sugar based on how inaccurate our measurements were. So same deal. And give it a really good stir because this stuff is very thick. Actually, I'm having a really hard time getting this dissolved compared to the other two syrups. It's almost like trying to dissolve gelatin. I think I'll have to add more soda to this. All right. So if I did my math correctly, this should be very similar to high fructose corn syrup. It is slightly sweeter, I think, but I really should be giving the other two drinks a taste. Yeah, I think it's definitely sweeter compared to sugar. But not by very much. And compared to glucose, wow, the glucose almost tastes like nothing now. This is definitely sweeter by far. So the invert sugar is our closest sugar here to high fructose corn syrup. And even though we weighed out equal amounts of the syrup after cooking it down, all these have 60 grams of sugar each, it's definitely sweeter. So in order of sweetness, it appears that the corn sugar is the least sweet, which confirms everything that I've heard. The sucrose is kind of in between, and the sucrose plus acid, which has been treated. So I think this is probably 50% sucrose, and the other component is going to be fructose and glucose. This is definitely the sweetest by far. So I'm definitely going to have to redo this experiment at some time, trying to match the sweetness of these, because I can't really tell a difference between the actual flavor. If anything, the corn sugar has less flavor than the sugar, but I think that might be because sugar has, at least the sugar that I used, has a little bit of contaminant in it. It was not quite as white as the glucose. But anyway, folks, I think that's pretty much going to be it. I've tested all these sugars, and I definitely need to do this again, making adjustments to the experiment. But other than that, that's pretty much it. Thanks for watching.